There we go. Go to files, get the file. It's called that one. Chapter 15 and 16 practice problems, yes.
You think you're gonna do?
I don't think it's needed. I really don't think it's needed, but we'll see. I usually just get my perspective whenever I get students on tutoring. And if they're not that confident, then yeah. Okay, did we all get them? The little file. And since Halloween was yesterday, my puppies and my cat, they were all matching. And if you actually came on Monday, you already saw the photos. Yeah. You guys saw the photos first. But either way, it was Monday. Okay, do we all have access to it? Are you good? Okay, I see some yeses. Actually, let's do two groups, two big groups. Sam, Juan, you guys are gonna be in opposite groups. You guys are gonna be the team leaders.
The team leaders?
Yes, I need two big groups. So. Juan, you come over here.
Where's over here? That's just such an art.
Here on the left.
I nominate.
Sam, you stay
I'm
there.
in the vicinity, right?
Sit closer. Sit closer. Move closer to Kayla.
I'm just a dude, man. Come on, bro.
Okay, you all of you are gonna be group one. Sam, the little group, you guys are group two. 3, 4, 5. And we have 3, 4, 5, 6, 7, 8. It's not equal, but still, let's make it work. Okay. Okay, are we ready? Okay. Talk in your groups, same like last time. Same thing. Work in your groups. This one should be pretty simple. So I hope that you're just gonna raise your hands as soon as you see this one. Just take a quick few minutes. Sam.
D.
D?
Wait.
We started? Okay.
We're ready, started. Okay, Sam says D. What about group one?
Hold up. I haven't even looked at it. I was just looking through my notes. What do you think, y'all? This is a team
It's
effort.
the meta app. Yeah.
Alright.
B, okay.
Oh.
Kayla, you are correct. We didn't read the answer choices carefully. No, I gave you all of the options. So yes, in this case, it's just B. Okay, now. You label the following molecules. This is from 15. Once you get the 4 names, just raise your hand.
A, polymine, B is aniline, C is acetyl. B is anisole.
Anisole. Did we have to look back at our notes or they would remember them? Who actually remembers those names, like by memory at this point? No one? Some of them, okay, I like that better.
I remember Danny.
Okay, that's good.
That one was easy, that's it.
Okay, awesome.
Yeah.
Okay, we're starting with the reactions now.
Alright, so what's the score?
Right now it's 1-1, right? 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 Wait. Don't scream. Don't scream.
What were your numbers?
Actually, let's make it more fun. No notes. No notes. From memory. Kayla, no notes. No notes.
15 papers that you meticulously planned.
You guys got the first one, right? Mickey, do you have an answer? Oh, okay. Someone from group one has the answer. You guys are two, one. Get together, start talking, guys. We're just gonna watch.
I got
Oh, ecology? No, evolution.
evolution, yeah.
Good luck. Okay. Show me the product.
You got it right here.
Okay, we're volunteering each other. Mickey, go for it. There you go. It's so empty right now. Like, what happened? Okay, that's true too. Yeah,
Well, it's because of the OH from the liver.
yeah, that's
Right.
true. That poor liver of most students.
I don't know how the extension works.
And so let me show it to you on the board. Yeah, you just add one line. And great job, Mickey. You guys are group one. To the right, we have group two. And thank you. So far, questions on that one? We should be pretty simple so far.
That's not a double bond, is it?
No,
Okay, that's just
that's just a single bond. There's no double bonds.
In her words, she said it's kind of wonky.
It works. It works. As long as it works. Very good. Mm. That's another point, yeah, I forgot. Sorry.
Yeah, but. A lot of people, Yeah, Halloween
Come on.
spirit.
School spirit.
Oh, had a reversible drink.
There. Who wants to switch to group two to balance it out?
No.
Make that.
No.
I was gonna say,
Prove yourself as the GOAT.
one can go back.
That's why she's the GOAT. We focus. I feel like my team.
I think it's always one team.
Okay, let's
Yeah.
do one big team. Let's keep it friendly. Okay. Answer for question number 4. Okay, let's do a combined group. Question 4. As soon as you get the answer, just raise your hand, whoever it is. Julie, I saw you first. Why the one on the left? Mm-hmm. Your carbonyl is a deactivator and then oxygen with lone pairs. Beautiful activator. So great job, Julia. So far, questions. We're just doing a basic review. Okay, seems like we're good. Go for it. Okay, ready for the next one? Or are we still taking notes? You guys let me know. We're chilling. Okay. That's not good, Sam. That's not good at all. And yes, progressively, we're going to start to get into the harder problems. So just take a few minutes. As soon as you get it, raise your hand. I'll give you that, Gayla. It looks funky, but it works. It works. Just give me the most logical product. Most logical. You can show me. I can give you the iPad. You can show me. Be confident. I know you know that. Okay, what are we having here? Not quite. What kind of reaction are you trying to do?
A methyl is an activator.
What chapter? 15. That benzene. Juan, look, that's how the camera auto-corrected it. I just wonder one bromine. That's it.
So it's not boron, it's bromine.
Bromine. Yes, it's bromine. For a second, you scared me.
I've never seen bromine with a three bonds like that.
Yeah, me neither. First time too.
Does it-
So that means there's a negative charge on it. Is there a negative charge on it?
And this is why I don't do problems of my own.
Let's get a long term on that.
Okay, maybe I went a little overboard with that one. So let's do it together. Okay, so do we have any answers?
Is there a positive charge on the BR?
Should we?
Should be.
What?
She wants to guess the first step.
What do you think is gonna happen? Okay. What chapter is this? 15 or 16?
Okay, 15.
15.
Right.
How does toluene look like?
It's the ring with a methyl activating group.
Which is an activating group. Okay. So that means that we're gonna go to the ortho and pair positions. Okay. Our reagent is this guy. I forgot to add the Lewis acid, so sorry about that. But either way, let's say that it was implied. So if we have a carbonyl group, what kind of reaction are we doing out of the 5 that we know from chapter 15? That's the whole name of the reactions. Is it a sulfonation? Is it a bromination? We have that carbonyl acylation, exactly. Carbonyls with an R group, those are your acyl groups. So we're just gonna do an acylation in here. For acylation, we just need to focus on that carbonyl. In this case, they're both symmetrical. It doesn't matter. Halogen is just your leaving group, so I'm gonna choose the one on the left. You can choose the one on the right. It doesn't matter. We know that eventually the leaving group is gonna go away. And then how do we think the product is gonna look like? No volunteers to try it out? The only product. The pair one.
It's just 5 carbon chain, 4 carbon chain, carbon on.
So we have our carbonyl over here. We have the bromine on the other one just hanging, and that's it. I flipped the toluene just for reference. I flipped it. But yeah. Because the methyl group in the toluene, that's an activator that goes ortho and para. So yeah, sorry about that one. I know that was very confusing. So. So yeah, I'm gonna stop making problems of my own and just stay with the book. Because I always get problems. Okay, ready for the next one?
Oh, yeah.
This one's simple. This one's simple. Conceptual stuff.
Is not a meta direct. When present complex. The meta is a deactivator, so we're looking for activators. So A,
So everyone agree?
B,
Why are we changing our answers?
no, A.
It is gonna be A.
Oh, I thought you were looking for more than one.
Oh, no, just one. It's gonna be A. What's A? How does that molecule look like? It's just a benzene group. Yeah,
Yeah, 'cause
pretty benzene group. benzene, it would be considered just a carbon chain, so orthopara. And then the rest of them, those are just your deactivators that go meta. And that's it. Simple, easy. As long as you read that question carefully, you should be good. So far, questions. Okay, next reaction. Multi-step synthesis. Give me the reagents.
A is the is the HCl and other substrate.
Do we all agree? What do we think?
Is this an acid?
No, it's a.
At the very
it's an
end, yes.
algination. Wait, what?
Yeah,
Oh, B's an acid.
yes.
Oh, B's an
How do you
alkylation.
replace the alcohol?
Cool.
B's an alkylation, because you're adding.
Kayla, you are correct. A, it's gonna be a protecting group. Which ones can I use? ECl5 or SOCl2. Any of those guys. They're gonna give you the same exact molecule. This is chapter 11, 12, one of those. Now, we have our acyl group. And then, let's look at our product. Our final product still has that acyl group over here. We're just connecting a benzene group. So practically, what you just formed, this is your reagent for acylation. So what's gonna be the reagent in B? An alkylation?
Isn't phenylring the alkyl group?
In this case,
Aluminum.
that's the Lewis acid that we need. I mean, yeah, I'll give you that. Benzene, it's just benzene. That's the only structure that we're missing. Because we're used to seeing the reactions backwards. First with the benzene and then with the acyl group. The acyl group is usually the one in the arrow, but in this case, it looks slightly different.
How is that an acylation though? You're not adding an acyl group.
I am adding the acyl group. I formed the reagent, which was the one in here. And then I'm practically, the reagent is initial.
In reference, you're adding the benzene group to the acyl group. so it's
Yes.
the reference to the acyl.
I mean, yeah, that would make sense, but we can see that we're adding the benzene group, not directly in here. So if the benzene group was directly connected to any of those points, then yeah, we could do some sort of alkylation. But in this case, because it's connected to the other end of the carbonyl, there's no way the alkylation can do that. Questions? We're just processing. We're very confused.
I mean, my argument is how you're not adding an acyl.
But actually, you have to add second grade, so it has to be like, the daylight in the. But it's like the starting.
Yeah.
Okay. For this one, what am I doing? Alkylation? Acylation,
Yeah.
right? Chlorine goes away and then you just connect it there.
So you're using the beginning as.
As basically my arrow.
substrate
Yes.
would be- okay.
Mm-hmm. So yeah, this way you presented the reaction backwards from what you're used to. Okay, any other questions on that multi-step synthesis? We're good? Okay, let's move on to chapter 16. This is your email chapter, yes. We talked about that one very briefly at the beginning of the handout. All of those reactions are going to create the same exact product. What is it? Ketone. Dipole, dipole.
It's like you're taking away the chlorine and you're adding the terbutyl, right? Or the OT.
Mm,
You're making an ester. Yeah. Oh, no. You're.
aldehyde. All of those reactions are going to lead to the same exact product, the creation of an aldehyde. Now, more importantly, I only told you guys to remember the second one, the one in the middle, because the first and the third one, that's mostly for Dr. Roche. But they all give you this little guy. Okay. Any questions so far? We're good? Okay, now we're gonna start to get into the reactions of 16. I'll wait for you, don't worry. I'll wait for everyone.
We only have to remember the middle one for last.
You have to remember the middle one. First and third, you don't have to. So yeah, just remember dipole, aldehyde. Okay, now the next few reactions are from chapter 16. Now we're used to a certain format of those problems. It was just a normal ketone and then some sort of reagent. So again, remember just the basics, like what's the basic structures that you need for the reactions. So let's start with this one.
Oh, this was in the practice.
Oh, I don't know. I didn't check it yet. Don't freak out. You guys can look at your notes in this portion.
Oh, that's right. The O gets protonated.
Does it get formed as?
No,
Yes,
a heavy keep acetone.
No, because you have.
Hemi or
two
full?
OHs. Two OHs, full acetal.
full because of the acid catalyst. So yes, you are correct, Sam
Okay,
and
yeah,
Emily.
completely protonates it. So then you'll have two ORs, correct?
What's the product?
No, it's just
Ring expansion.
it's just two ORs, dog.
Take your time. Just remember the basics. It's gonna look a little funky.
It would make a ring, right?
It's gonna make a ring. Do you have an idea of the product form?
I could give you.
Okay. Go for it.
Then you'll have an OR here. Double. Like that. H is it's two carbons, so it'd be like. Be like that.
You got it.
Alright.
Great job, Juan. You just missed one little carbon in between the first ring and the carbon chain.
Oh, true.
One more carbon and there we go. Great job. Okay. Questions on that one? Do we see it? Do you guys want me to show you the mechanism at all? Okay, let's go through the mechanism. Let's see where everything's going. Okay. Don't get scared. It's not too bad, not too bad. Okay, so first we have our dear acid. What does the acid do? It makes the electrophile more electrophilic. So my oxygen in here is going to be gaining one of those hydrogens. And let's do it small so we have space. Then I have this guy. Okay, so far we're good. Now, once we do that, now we can proceed with whatever reaction we're doing. In this case, we have our dear alcohol groups. So in this case, you're going to choose either of those oxygens. Okay, doesn't really matter. The oxygen is going to do the nucleophilic attack to my carbon. Since it's nucleophilic, it's getting connected there. And to not break the octet, we push up the electrons towards the oxygen. Okay, so far we're good. Okay, seems like we're good. So what do we think is going to happen at this point?
The hydrogen on the ester leaves, or the ether, I'm sorry.
So yes, we want to neutralize everything, so we can just assume that the conjugate base of the acid that you were given is just going to take it away. So now we have this guy. Whoops. Okay. So far, what's the name of that molecule that I just formed?
This one?
Yep.
Or if we talk about like a heavy.
What of those?
stuff,
What do you think?
It's OHOR. Pretty sure it's heavy ester.
It's the hemi form. And technically, yes, we also have an ether and alcohol groups. But the whole thing combined, that's just your hemiacetal. Now remember, acids, they're very strong catalysts, so the reaction is going to happen all over again. And actually, let's show it step by step. So to make this better, we're going to be transferring over that hydrogen because the oxygen is going to attack the hydrogen and take it away. So now we're going to have this guy. Oops. Hydrogen. Hydrogen. Okay, now we have this guy. Now, same process. Your oxygen is going to attack your carbonyl. Nucleophilic attack, it gets connected there. And then, to not break the octets, we get out the water, which is going to be our leaving group. Oops. And there we go. Okay, question. I know you guys are not used to that style of question, so it's okay.
I will be honest, in my head, it didn't play out like that.
Oh,
So I just knew that the sulfuric acid was gonna take away the H's, and the 2 carbon chain is pretty much gonna be attached to it. It's kind of like that meme where it's like we use a different equation and you got the right answer. Like just exactly.
Actually, yeah, that just happened. But we know the shortcut for this reaction, right? What was the simple shortcut? Don't look at this guy.
Chop
What
the
do-
head,
Chop the head and
the arm.
you're gonna grow 2 arms. So let's apply the shortcut in here. So we see our carbonyl. We know that the head is the oxygen. We just chop it off. So we're just gonna start by drawing those legs in there. Okay, those are my legs. Now I know that instead of having a new head, now I have 2 little arms. And in this case, because I have an alcohol group, I know that I'm either gonna create a hemiacetal or a full acetal. But because I have my acid, I know that it has to be the full form. So full form, we just know that both arms are gonna have an oxygen. And then connected to that is whatever R group you had in the alcohol group, which in this case was just 1 and 2 little carbons. Whenever you see a molecule that has 2 oxygens, 2 alcohol groups in the same way, it's always gonna make some sort of cyclic structure. Okay, so that's like the main important part of this guy. So we have 1 and 2. So you can solve this question by doing the full mechanism, or we can just do the shortcut. But while you're practicing, until you get the gist of it, just do the mechanism to see where everything's going, okay? And then once you feel really comfortable with that, then you can just chop off the heads. Okay, so far questions. We're good? A little confused. Okay. Let's give it a try to the next one. And this one is actually a little bit harder because you're not going to get the product that you expected, but for a specific reason in the mechanism.
Would it make the bicyclic?
So it's gonna be intermolecular reaction and form of
Yeah.
bicyclic.
You're both correct.
So you're
Anyone?
chopping off the carbonyl.
Sorry.
Rotate it inward and just wedge it into a cyclic compound.
Give it a try.
MIM, would you make bonds between? Oh, that's a little bit.
So far, so good.
So that's all I got.
So look how in the initial molecule, we have 2 oxygens, the one from the alcohol group and the one from the carbonyl, right? Now, the one that you showed me, that comes from the alcohol group. So where is that oxygen in the carbonyl?
H3O, H2O.
No,
Doesn't it get pronated and?
That's what I'm saying. It doesn't become H2O.
no, it's still there.
Oh, so it's like a dual ester, or either. So O'Reilly's out of parts.
No. So great job, Sam. Okay. So we know that the carbon over here in the carbonyl portion, it's this one. The oxygen in here, it's still there. It's still hanging around,
Oh,
but now we're just protonated. We're not kicking it out as a leaving group because we only have 1 mole of this guy. So we know that just based on what we were given an alcohol group that's an acid. So we know that.
Oh, so that's not the OH. That OH that's added is actually the carbonyl plus a protonated H. Like an H. Gotcha. I understand.
So just by looking at the initial molecule. Yes. Yes.
so you're pronating the carbonyl, and then, rotates around a single bond, and then that pronated carbonyl, that's to the.
Okay. Do you guys want me to show you the mechanism?
Not the
I Kind of.
one, just like the reduced.
Yeah.
Okay, let's do full and
full.
short.
Okay.
Okay.
Sounds
Both of them. If you don't want to look at the full one, just look down, look at your iPad. Okay. So this guy, we start with our acid, remember, it makes the electrophile more electrophilic. And then we still have the same exact molecule over here. And now I have a positive charge in that oxygen. Okay, now at this point, my alcohol group is going to be doing the nucleophilic attack. So this guy attacks my carbon, it gets connected there, and then to not break the octet, push up the electrons.
Right, you said that the conjugate base picks up that process.
Let me just move together. So far, we good? Okay, it seems like yes. So now just your conjugate base comes back. Let's just do an A minus. Takes it away. And that's how you end up with the little guy in here. What kind of group did I just create?
Hemi, keto.
You were doing good. It is hemi, but it's not keto. It's acetal.
It's a keto, they're both carbons.
Mm-hmm. We're starting with an aldehyde in here. So it either has to be hemiacetal or full acetal. So in this case, because our arms don't match up,
Oh, there's one hydrogen out there.
yep, hydrogens are not always going to be drawn out. Acetal, and that's it. Okay, questions on that one? We're good? Okay, let's give it a try to another one. It's presented slightly different as well.
Are you just swapping the OHs for ethers?
No, hold on. It's, so you're actually protonating that ketone, you see that? Right,
Mechanism wise, yes.
right, so you protonate the ketone. Then it creates a carbocation bottom, which then gets attacked by an alcohol.
That's not bad.
No, okay. She made those faces.
What do you think? What's the product?
That's him, not me.
Give it a try.
No, she made those
Give it a
faces that
try.
mean was a problem.
Give it a try. You were correct when you were saying that.
Oh, okay.
Initially,
Yeah, yeah,
yes. Just trust your gut. Really good. Now, look, we have a molecule that has two alcohol groups in the same molecule. We saw that in a previous reaction. We formed a cyclic structure. So how would you modify it?
That's definitely not it. Okay. What? Say that?
Say it again. So we're going to have one carbon connecting those two oxygens. 1, 2, and now that carbon has the legs of that ketone. And there you go. That's it.
You chop the heck, no arms. I see the mechanism. 'Cause
Okay.
you do protonate that O with the sulfuric, right?
Great job, Sam. Don't get stressed. Don't get stressed. I know it's a lot. They look really hard. I chose them for a reason.
I just can't even focus on it.
That's true. Okay,
So, can we go over the mechanism for this?
yes. Okay. So we know first step, very obvious. Acid makes the electrophile more electrophilic. Okay, so we have this little guy. Okay, now either of those oxygens is gonna do the attack. I'm just gonna choose the one on the right. Nucleophilic attack, pick up the electrons. We have OH, oxygen. Okay, now this oxygen is gonna be taking this guy. Okay, now, very simple. We know that oxygen is gonna be attacking our carbon. I drew something wrong, didn't I?
Not sure. So, I mean,
That one's absolutely correct. This one. Oxygen takes that one. We create this little guy. I just drew it differently. Same thing. This one has tomorrow. Sorry, it was the opposite way.
oh, 8 a.m.
8 a.m. part. And that morning traffic.
Oh, it goes.
Yeah.
It's
6 a.m.
salt, is that better called salt?
Huh?
I said, you said salt, and I said, is that better called salt?
No.
Salt good?
Okay, now we're correct.
I'll worry about the mechanism. Right.
Don't worry about it right now. Just focus on your exam.
Wait, are you posting this tonight? We're not done with it.
We are 1, 2. I'll just give it to you guys.
Appreciate it.
So yeah.
Definitely looking at this. I cut the meat.
Let's be careful.
I know, you know, I was thinking. Friday, definitely, yeah.
And now we attack, and that's how we end up with the final product. Okay. Question. We're good?
Hold up. What did you do between, you say they attack each other?
Those oxygens?
Right, so between that step that you did and the left.
Oxygen attacks hydrogen.
Right, so you're saying they attack each other, that's what it looks like.
Oh my God, wait. I'll fix it in the MCQ. Don't worry about it. I'll be starting the answer key. Yes. I'm sorry? Say that again, one more time. Yeah. Oxygen in that ketone, and then just connect it. Mhm. Okay, I'll be posting the answer key tonight, so you guys can review it. I'll include the mechanism. So don't worry about it, and also the shortcuts. Mechanisms are shortcuts. But we'll start chapter 17 Friday.
Did we finish chapter 16 today, class? But-
Yeah, because
So we're
I
doing
asked him.
17 Friday.
Yeah, he said he's gonna start on Friday. So yeah, we're moving on.